Alright, so let's move on to our next topic. Our next topic we are going to tackle is on simplifying. But this is a different type of simplifying, because in this type we're going to simplify roots. And specifically we're going to be simplifying square and cube roots. Now, remember yesterday we talked about when you take a square root, if it was the square root of 36, we would get 6. But if it was the square root of 24, there is no perfect square for 24. And we have to kind of think about how can we get a better answer than just saying, oh, well, it's between this and closer to this. We don't want to leave it as that because that doesn't help us much. And we could actually do an interpolation. Yeah, big word, don't worry about it. And figure out what the decimal is. But again, it's a never-ending decimal, so that doesn't help us either. So we want to look at something that would be more helpful, and that is to simplify it, to make it just a little bit easier that we might be able to work with. One way we do that is the following. We start by taking 24. And we look at the prime factorization of 24. And as we know, the prime factorization of 24 is 2 times 2 times 2 times 3. And now what we're going to do is we're going to look for any pairs of numbers. Because if I could find a pair of numbers, the square root of that pair of numbers will just be that number. Watch what I mean. If I look here, I see that there's a pair of 2's. Well, isn't 2 times 2 4? And the square root of 4 is just 2. So if I literally was to take the square root of both sides, then I could say that the square root of 24 is equal to the square root of the pair of 2's, which I can take out to become a 2, and then what's left is 6. So the answer is 2 root 6. Let's take a look at another one of these. What if I asked you to find the square root of 27? Well, that's the square root of 3 times 3 times 3. Now, again, I want to look for a pair of numbers. And I see that I have a pair of 3's. So in this case, I'll pull out that pair of 3's, which the square root of a pair of 3's is just 3. And what I'm left with is 3 root 3. How about this? The square root of 72. When I do the square root of 72, the prime factorization is 2 times 2 times 2 times 3 times 3, times 3. So I have 2 times 2 times 2 times 3 times 3. I notice that there's a pair of 2's and a pair of 3's. So I can pull those out of my square root. Pull those out, and what I get is 2 times 3 root 2, or 6 root 2. Now, just to give you a little background on why I could actually do that, there's a rule that says if I have the square root of a product, I can actually make this the square root of A times the square root of B. I can separate those out. So when I go back to the square root of 72 for a second, I add the square root of 2 times 2 times 2 times 3 times 3. And I could actually say that this is the square root of 2 times 2 times the square root of 2 times the square root of 3 times 3. Now, I'll do a little bit of changing here and make that the square root of 4 times the square root of 9 times the square root of 2. Well, here's why this works. The square root of 4 we know is 2. The square root of 9 we know is 3, and we don't know the square root of 2. So that gives me, again, my 6 root 2. And that's why this actually works. Okay, your turn. I would like you to try the following. Take the square root of 48. Take the square root of, let's do 108. And let's do the square root of 288. Pause the video and try these problems. All right, let's see how you did. If you did it correctly, the square root of 48 would have given you 4 root 3. Square root of 108, 6 root 3. And 288, well, that's 12 root 2. If you got them all right, great. If you didn't, I want you to ask me tomorrow how I actually did these problems. Now, just for fun, think about if square root we look for pairs, what would I do if I had the cube root of 16? Yep, I'm going to look for triples. Well, in this case, we know the square root of 16 is 2 times 2 times 2 times 2. And I see 3 2's there, so that gives me 2 cube root of 2. Here, give you one to try. Why don't you look for the cube root of 54? You try that. Okay, if you did that right, you probably came up with 3 cube root 2. If you didn't, ask me in class. Let's see how well you did on that. So that is how you simplify square root. Oh, you know what? Let's look at one more. Go back to square roots for a second, because I kind of think I maybe made this a little too easy for you. Actually, not too easy, but let's step it up a bit. What if I gave you the square root of, 18x cubed y to the 5th? Yeah, I introduced variables into this. It's not a difficult thing to do, though, because, again, you're just going to look at the square root. 18 is 2 times 3 times 3. X cubed is just x times x times x. And y to the 5th is y, 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 y. And I'm telling you it's because, but that's besides the point. So we're now going to look for our pairs. We have a pair of 3's. We have a pair of x's. We have a pair of y's. And we have a pair of y's. So when I pull those out, I have a 3, an x, a y, and a y, root 2xy, because that's what's left inside there. Simplifying a little bit more, what I get is 3xy squared root 2xy. All right, let's have you try one of these. Let's have you do the square root of 32xy to the 5th. Stop the recording and try this. If you did this right, you should have gotten 4y squared root 2xy. Did you get that right? I thought you might have. If you didn't, again, now I want you to ask me in class tomorrow. I want to make sure you're totally understanding how to do this. With that, that will end today's lesson, and I'll see you tomorrow.